Okay, guys, this is problem number 9 on the review sheet. So we're looking at the total change in enthalpy of a system of 25 grams of solid water going from negative 50 degrees Celsius to liquid at 50 degrees Celsius. So when we look at the graph, this covers kind of 3 parts. So it covers all of A, 50 to 0, all of B, that phase change at 0 degrees Celsius, and then half of that C segment, so from 0 to 50. So that means we're going to need to do this in 3 parts. So first we're going to find the heat for segment A, which is the negative 50 to 0. So we remember that this is solid water, so that first part below 0 degrees. We are going to find the heat for this. So remember, enthalpy is equal to heat, and heat is mass times specific heat times change in temperature. So we have 25 grams of water, and it's solid water. So the specific heat value we want to use is the 2.05 joules per gram degrees Celsius. And then our change in temperature is final minus initial. So 0 minus negative 50. So it'll be a change of 50. So when we do that calculation, our heat value is 2,562.5 joules for the first segment. The other segment where we're going to be able to use this equation is the liquid water segment, and that's C. So we're going to use the same equation, but look at the second part of that. So we've still got 25 grams. Now we're liquid water, so it's going to be 4.18 joules per gram degrees Celsius. And then this is from 0 to 50. So final minus initial is going to be a change of 50. Our heat value is going to be 5,225 joules. So even though it's the same amount of temperature change, it is going to be a higher value because of that specific heat. It is more difficult to heat up, or takes more energy to heat up liquid water than it does to heat up solid water. So these are the 2 parts of the graph that have a positive slope. The third part of the graph is section B, and that is where melting is occurring. So we are given the heat of fusion in our lab, and so we want to make sure that that's in the correct unit. So we're given a heat of fusion as 335 or 333.5 joules per mole. Now what we know though is that we actually have 25 grams, not 1 mole. So we need to convert that and figure out how much energy we have in 25 grams. So we'll start with our 25 grams. We need to get that to moles using the molar mass. And then we can use our heat of fusion value as a conversion factor to get to joules for that segment of the graph. Finally, our last step then, we need to put all of that together. So we're going to add our first segment, which is A, and then our second segment, which is B, the 462.78, and then that third segment, which is from 0 to 50 on C, to get a total enthalpy change of 8,250.28 joules for that entire process.